Hi, my name is Kevin. Welcome to the video about the Tower of Hanoi. Description: the Tower of Hanoi is a mathematical game consisting of three vertical routes A, B, and C, and different discs of different size. Before starting the game, all the discs must be placed on route A, or the from largest to smallest size, that is, the largest in the lowest place and the lowest one in the top. In the computer world, it is used as an example of recursivity by excellence, depending on the number of disks, depending on the complexity of the solution. The game consists of the following: begin in the starting position, transfer all the disks to the road B, but also place from major to minor in the same order in which they were placed on the road A. For the transfer of this, we can use road C, but the condition of only one disk can be moved at the time, and large disks cannot be on a small disk.
Hey Jonathan, now I will talk about the rollers of the game to play the Hanoi Towers. First, we will use 4 disks in one of the axes, in a decreasing way with the largest on the in the base. The game consists of moving the disks this axis to any two remain ones where any of the 3 edges can be used throughout the development of the game with successive movements. But bearing in the mind that only one disc should move at a time. Being prohibited, place a large diameter disc on the one of a small diameter. For example, the disc 1 to tower 2 and the disc 2 to tower 3. For the moment, no rule breaks. Now, if these 3 move to tower 2, I am breaching the rules. The rule says a lower disk size is below a larger size disk. This move is not possible to make the disk 3 return to tower 1. Now, I will conclude the game based on the rule explanation above. This how the game on Hanoi Towers is made, then we will go to the explanation of the code. Thank you.
Well, hello, my name is BITMAN. I'm going to talk about the Java coding for the exercise the Hanoi Towers with recursing below to the explanation.
Well, we continue. Now I will explain the program code. To start, we create a project where we go a package with 2 classes, which the first class is called recursive and the other class is called main. In the class recursive, have a one method called Hanoi. This method have 4 attributes. The first attribute is the letter N, will be the number of the disk that the user wants the program to sell through the rules of the Tower of Hanoi. Then, in the second attribute is origin, which takes the place the first towers. Then, the next attribute is the attribute assistant, is the attribute auxiliary. In this case, represent the second tower. Finally, the last attribute is the destination. This attribute represents the third tower in the game. Then, an if condition is created, which has the condition that if the disk is equals to 1. The disk moves directly to the last tower, ending the game. But if is greater than the disk entered by keyboard will be subtract 1 and the other attributes in normal condition. After comes the system print which of the print screen attributes of the origin and the destination. Then the Hanoi methods change the order of the attributes, where the first number of the disk will go -1 after the variable assistant, the attribute origin, and finally the attribute destination. We went to main class, where we create an object will help us instead to the recursive class to call the Hanoi method, which has recursion. Declare object for the reading data. In this case we use the scanner. Then read with the variable n the number of the disk the user wants. Finally, we call the Hanoi method in which we send the attributes of the number of the disks that the user wants. Then we send attributes 1, 2, and 3, which will represent the towers of the game. Well, I finished the explanation of the code.
Hi, my name is Marco Sanab. I will make the resolution of Hanoi Towers with the steps shown in execution of the proof. For this example, if I enter the amount of the 4 disks, the program showed me 15 steps to follow. The steps are move the disk, the tower 1 to move the tower 2. The disk in the tower 1 to move the tower 3. And the disk in the tower 2 move the tower 3. And the disk in the tower 1 to move the tower 2. The disk in the tower 3 to move the tower 1. And the disk in the tower 3 to move the tower 2. The other step is the disk in the tower 1 to move the tower 2. And the disk in the tower 1 to move the tower 3. The steps are the disk in the tower 2 to move the tower 3. And the same, the disk in the tower 2 to move the tower 1. And the disk in the tower 3 to move the tower 1. The disk in the tower 2 move the tower 3. And the disk in the tower 1 move to tower 2. And the disk in the tower 1 move of the tower 3. And finally, the disk in the tower 2 move to tower 3. And that's it. In conclusion, with the realization of this program, it was possible to determine the amount of steps to follow depending of the numbers of the disk. Thank you.